Sasmita KG at Sastra University. Today, I'll be presenting my internship project on microcontroller simulation. So, let's get started. Presentation will cover the following topics: an introduction to microwave ovens, the topics I learned during my internship, the key components like CLCD, matrix keypad, timers and microcontrollers, and finally the project implementation. So, topics you learned during the internship. So during my internship, I gained hands-on experience in the embedded C programming, microcontroller peripherals, timer and interrupt handling, LCD and keypad interfacing, and simulation using PICSIMLAB. These skills were crucial in understanding and implementing microwave oven simulations. So during the embedded C programming, I learned how to write efficient code for microcontrollers, handling I/O operations, and optimizing performance for real-time applications. So I learned the basics of microcontroller and its peripherals. Same with LCD, keypad interfacing, simulation, and testing using PICSIMLAB. So moving on to what is a microwave oven. Microwave oven is a widely used kitchen appliance that heats food using microwave radiation. So the device offers different cooking modes inclusive of micro mode for general cooking, grill mode for meat and bread, convection mode for preheating and baking. And the user can set time in the convection mode accordingly. So coming to the requirements of this project, to implement the project we use MPLAB X IDE, the XC8 compiler, PICSIMLAB, a PIC16 F877A microcontroller, 16x4 character LCD, a matrix keypad, timer 2, tactile switches. These components were essential for creating an accurate simulation. So to the microcontroller, all the other peripherals are interfaced to it. So coming to the difference of what is a microprocessor and a microcontroller, what is the basic difference between it? So the microprocessor consists only of a CPU and requires external components, while a microcontroller integrates a CPU, which is like a computer, so which has memory and I/O peripherals into one chip. So it becomes like a miniature computer. Microcontrollers are used in embedded systems like microwave ovens due to their compactness and efficiency. They use external bus to interface the ROM and RAM and other peripherals, and whereas the microcontroller uses an internal controlling bus. Microprocessor, though is expensive and complicated with a large number of instructions to process, but it's very efficient. Coming to the PICSIMLAB. So PICSIMLAB is a simulation tool used for testing microcontroller projects. It allows debugging and validation of embedded system before hardware implementation, reducing errors and improving efficiency. So in this PICSIMLAB, we have used the PIC16 F877A, a PICGenius microcontroller, and here I've attached the basic architecture of the PIC16 F877A architecture. So coming to the CLCD, it's a character liquid crystal display. In our project, we have used 16x4 CLCD to display user inputs and system responses. CLCDs operate in two modes, 4-bit mode and an 8-bit mode with ASCII and custom character support. So there's a data sheet to it with the use of which we have implemented all the lines like the bar graph and everything which is used in the powering on of the first system. Matrix keypad. Matrix keypad is a set of tactile switches arranged in a fashion of row and column format. So commonly used in devices like digital lock and microwaves. So it enables efficient user with minimal microcontroller input-output usages. So what it usually works like is, so whenever the switch is grounded, uh, input is received to the controller. So whenever the R1 and C1 is grounded, the switch number 1 is sensed. So this is how the other switches also work. Going to the interrupt service routine. So it is a function triggered by an interrupt request from hardware or the software. It helps the microcontroller handle real-time tasks efficiently by pausing the current operations, executing the ISR, and resuming the previous process. So when an interrupt occurs, the microcontroller completes the instruction that is being executed, then it disables the global interrupt enable, places the address from the program counter on the stack. So it is a communication process setup in which an internal or external device request to the controller uh, can, uh, can allow to stop the processing. So it goes back to the processing where it was interrupted. So it does that by polling. So the process where the computer or the controlling device waits for an external device to check the readiness or state, often with a low-level hardware. So timers are essential components in embedded system used for delay generation, event scheduling, and real-time clock functionalities. In this project, timer 2 was used to manage cooking durations and preheating cycles. So here it has many applications such as measuring time and generating delays. It's a software designed to count the time intervals between the events. Resolution is also called as the register bit. It can be either 8 bit, 16 bit, it can be whatever. So tick is referred as the change from one number to the other number. It may be up count or down count. So scaling may be pre-scalar or post-scalar also. So coming to the project implementation. So now let us discuss how we implemented the microwave oven simulation. We programmed the microcontroller to handle user inputs via the matrix keypad, display outputs on the CLCD, and control cooking times using timer and interrupts. So so the first, whenever we reset or whenever we load the microwave project, the hex file, whatever is visible for the first 5 seconds is the powering on, the microwave oven, and 2 bars which we have used. So going on to the next thing. So those are the 4 modes of microwave oven. So we have actually defined 4 modes of microwave oven, which is micro, grill, convection, and start. The micro mode is used for general cooking operations operating at a maximum power of 900 watt, and the grill mode used for cooking bread and meat, allowing adjustable time settings. The convection mode allows preheating to a specific temperature before cooking. Start function initiates the selected cooking mode and manages the process. Like the tactile switch 1, it chooses the micro mode, which displays the power of 900 watt, and it goes to the next step, which I'll be showing you in the further project implementation of the screen recording. Uh, Going to the grill mode. So it asks you to enter the time, how much you have to grill, and when you enter the time, and it asks for two things, which is either clear, star is for clear, and hash is for enter. So when we enter it, we see this type of a screen, which has start, resume, pause, and stop. So as the name says, it does the same thing, and until the time is complete, it keeps on running. And going to the convection mode, so it asks for the user for the temperature. So when the user enters the temperature, it goes to the preheating mode. I have added one more thing. So when the temperature is below 120 degree, it it takes 1 minute preheating. So above 120 degree, it takes 3 minutes of preheating, and above 250 degree, it will show an error. So the fourth mode is the start mode. So start mode will by default go to 30 seconds. So when the 30 seconds is over, it shows that the cooking time is up. So thank you. According to this, my PPT is complete. I'll be going to the coding part. Internship, I gained valuable experience in the embedded system design, microcontroller programming, and real-time simulations. So this project provided practical insights into the functioning of microwave oven and their embedded control system. Uh, Thank you for your time and attention. I look forward for the feedback. This is an embedded C program for controlling a microwave oven using PIC microcontroller. The program includes features like mode selection, setting time, temperature control, door status check, and operation of fan and buzzer. Now we'll go through the code step by step. So before that, I have actually included the CLCD file, matrix keypad, timers, and the source files of the same CLCD, ISR interrupt request, and matrix keypad and timer, so that it's very easier to integrate all of that into the same new main.c code. So now let's go to the coding part. So first, until here, I have done the header and configuration files. So these header files provide access to various functionalities like LCD display, keypad input, and timer. And this pragma config WDTE equal to off just signifies the watchdog timer WDT. It is used to reset the microcontroller if it hangs. So here it is turned off. And I have initialized all the global variables until here. So where the operation mode stores the mode which is selected, micro, grill and all. And the reset flag restores the reset conditions. Minutes and seconds stores the cooking time. Heat flag tracks if the oven is heating. Second array and minute array holds formatted time values for display. So here we'll go to the initializations. So in this, the init config has init CLCD, init matrix keypad, init timer 2. So what all this has is, this initializes in init CLCD initializes the LCD setup for display. The init timer 2 configures timer 2 for continuing time, counting time, and the buzzer and fan are initialized here. Then the interrupts are enabled. That is for the peripheral devices and the global operations. This is for the peripheral and global operations. We are going to the void main now. So the main function has a lot of things to go through it. So the key features are basically we'll just see what all are the key features. We're just function calling everything. So while of one, while it's always like infinite loop, we just went if the operation mode is micro, operation mode is grill, operation mode is convection. So whatever it is, this is going to work. Else if the key is 1, it goes to the micro mode. Reset flag, we have resetted it. Then we have just displayed it. So the CLCD print condition just prints the string array power equal to 900 watt. This shows that they're aligned to 0th place. Then we have given a delay of 3 seconds. Then if the key 2, it goes to the grill mode, same with the reset flag. And if it's with the key 3, it goes to the convection and convection reset. Grill for else if the 4 is pressed, 30 seconds of timer will automatically be on, and the operation mode, it will display the time. So if nothing, if else, like in that, if the time display is greater than 30 seconds, it just subtracts 60 seconds. If it is paused now, the timer on is paused and the fan is on. If we press 5, it just pauses. If we press 6, it just stops. So we can select which key we want. So moving on to the mode selection function. So we'll see what all mode selection functions are there. It's after the selection of the 4 main modes. So we'll go. So when something is not pressed, it will display the modes as the default condition. So we have case start, case time display, and then case micro. Case micro has set time, and grill also has set time. Convection has heat flag, and it has set temperature. So we're just setting the flags right here. So this handles different microwave modes, and then we'll go to the convection mode. This convection mode, first it sets the temperature using set temp of key. If heating is completed, which is success, so moves to the setting time. If paused or stopped, the fan and the timer turn off. So this is for the convection mode. So this is for the powering on of the, which is the main starting condition, the powering on. So what I've used is, I've used CLCD patch, it is for characters. So I've used the blocks which is on the top and the bottom most of the CLCD. Then in the middle I've printed the powering on and microwave oven. The block should be of 16 characters, so I've used a for loop with a delay of 1.5 seconds. So for the modes to display, I've used same CLCD print, micro, grill, convection and start. Then clear display I have written, so CLCD write function I've used. So for set time also I have used. So how it sets time, the key all should be cleared first. If the reset flag is greater than 11 and everything, the CLCD print. So all for the setting of time. How much it should blink, how much the CLCD should print, everything. So we'll go to the door status check. So what this door status check does is, if the microwave door is open, it pauses the cooking, turns on the buzzer and displays a warning. Once the door is closed, it resumes the operation. So this is for the displaying of time. and we have printed here for the start, pause and resume. Same we have done, like what should be done if the fan is off, the cooking timer is up, everything we have defined it here. So to conclude the coding with, this program allows the PIC microcontroller to control a microwave oven with the 4 modes and safety features like door checking. To end up with this code, this main.c has a lot of other functions included in it without actually defining it again. So we've used the function calling and integrated the same thing in the whole microwave project file, and this file is already clean and built. So it's already clean and built, which can be loaded to the PICSIMLAB, and this PICSIMLAB load hex file then goes to the uh, simulation of the microwave project. To start with the project implementation, I have opened the PICSIMLAB. Already I have chosen the board of PICGenius and the microcontroller as PIC16 F877A. Then the clock of 20 megahertz. Then I'm loading the load hex file, and I've already opened it from my desktop in the Embedded System Internship microwave project. Then I'm going to the disk, default, production, then the hex file. I'm opening this. So it's showing powering on microwave oven with the blocks on. So now I'll be showing what happens when I click every button. So I'm clicking the micro mode, which is showing power 900 watt as default as we set. So it's asking for us to set the time. So I'm entering some 7 seconds probably, 7 seconds and 0 minutes. Okay, let it be 7 seconds and 0 minutes. So for entering it, I'm pressing the hash. So the fan is running and the microwave is cooking. So if I want to pause, the cooking time is up, sorry. So I'll do it again. I'm clicking, powering on. Some 20 seconds I'll start with it. And so if I want to pause, I'll click 5, which is pause. Then if I want to resume or start again, it's starting from the same time. If I want to stop the whole thing, I'll click 6. It goes to the initial stage. Then if I want to go to the some other mode, I'll go to the grill mode. So it's asking me to set time again. So if I'm setting for 20 seconds again and entering it, it is doing the same thing. So if I want, I'll start. Stops. Resumes. So then I'm stopping it. So in the convection mode, asking me for temperature, and I'm entering some 23 degrees Celsius. So this is going to preheating for 1 minute. So the same thing, if I enter it above 120 degrees Celsius, it takes 3 minutes for preheating, and if it's above 250, above or equal to 250, it will show error. So I'll show all the cases here. So let's just reset it because it's taking a long time. We'll go to the convection mode again, set the temperature for 250, 6 I'll press, I'm entering it, so it's showing invalid temperature. So, and for the same case, as I told, if I put some 213 degrees and enter, it's probably take 3 minutes. Reset the cases. I'll go on to the fourth mode, sorry. Start mode, which is for default 30 seconds as you saw. And then you can start, pause, stop. You can do whatever you want. We'll see until the case when the cooking is complete. But I want to show you one more case right here. When I press RB3, that is the door open case. So it just shows that the status of the door is open and the heater, the fan is not running. So it's asking you to please close. So when I remove, it starts the process again. Yeah, I'm just waiting for this to complete. So it's showing